Hello, everybody. Today I'm going to walk you through my solution for parking prediction, hosted by BitTiger, sponsored by SmartGain. All right, so basically they provide transaction datasets that they have entry time and exit time, and the goal is try to predict the occupancy number for all the hours um, in February 2016, and also build a web app for it. All right, let's dig into it. So this is the data set that they provide. It's pretty big, and it only have these two rows that you need to transform in a way that you can actually use it. So this is the part that I did to transform it, and basically I want to get a date and a list of the um, numbers of the cars in the garage. So I using the data as the key, and the value is the list of the number of the cars, and for and index is the hour. So for example, this would be 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. Have like 56 car in the garage on that day. All right. So yeah, so that's the data pre-processing. After that, I will get a hourly.json file. It's basically this data you're looking at. I try to plot a little graph to have a kind of big picture of like what's the data look like. Right? So I plotted out 2013, 14, 15. Basically, those are the same weekday of that month. So, for example, this could be like the second week of February. So like this could be like second week Monday for February 2013, and this could be the second week of Monday for 2014 February, and same thing. So interesting finding is after I plot like couple similar one, I find out it seems like 2013's number is really low compared to 2014 and 15. Then I come up with an idea to plot it out more widely, like a monthly calendar. And this is what you can see right now. So in order to generate this graph, you actually need to do another processing. Basically, for this one, I want to show the daily number of the cars in the garage. So I basically uh, reprocessing another uh, part of my code to generate a daily.json file. So this will tell me on May 14, 2013, there were 438 cars in that garage on that day. So the similar things for the rest. After I plot this out, it's really interesting to see that 2013 it's really have less cars compared to 14s and 15. Let's look at this. That's like 400, but here it's like 3,000. So like that's almost 10 times. So that's kind of giving me like a red flag. Say, okay, don't include the data in 2013 or 2012. So, so I only use in 2014 and 15 because they're more representative compared to 2013 to predict the number in 2016. Yeah, so that's the interesting find based on the playground. And then I'm also looking at what's the other data I can use, right? So let's go back to here. So based on the graph, you can probably see over here are all white. White means like there are really few cars in the garage, right? And if you look like deeper, okay, that's November 28th, November 27th, December 25th. That looks like it's holiday, right? But not all the holidays have the same thing at this though. So uh, there's a library holiday that that you can use to get all the national holiday in the US for that year. So I basically compared to each holidays on the graph to see whether that's actually the truth, right? So I noticed that they also include things like Veterans Days and Columbus Days, and they're not very um, actual, like they're not actually the holiday showing on the graph. So, for example, Veterans Day is on 2015. That's 11 11 11. Yeah. So, 2015. 11, 11. So that's 3,000 something compared to the other similar uh, Wednesday in November. It's can't really tell that's a holiday compared to uh, Thanksgiving or Christmas, right? So simply because of that, I kind of manually select all the dates based on what is showing on the graph to say, all right, if this days happen in the data set, I will flag it as a holiday. So that's the first finding based on the parking calendar. And then I start my data processing part. First, I will load all the data into Pandas. So this is so these were the input data. It will be the date of list of hour. I basically make it to be hour have its own column and it have its own number of parking. So the number of parking will be our target variable. And then um, here is basically a bunch of feature engineering. Right? So I extract the week number features, weekday features. So here's an interesting thing. Actual work day technically is supposed to Monday to Friday, right? But based on the parking calendar, it tells me uh, Friday is not kind of work day because it looks like people getting uh, a little bit slack on Friday compared to all the other days. So I simply just didn't include that in the workday, in the actual workday. But the weekend would be 6 and 7. And then I also have days features. So uh, yeah, yeah. So the days features is basically uh, whether that is actually a holiday or not, right? So basically getting uh, so the list of the holiday that I was defined. Then it's extract the hour feature, and this the my opinion of the hourly bank. So from midnight to 5, and from 9 o'clock to midnight, that's a bucket. And the reason for that is in the playground I noticed the trend is like this, right? From midnight to 5, from 21st to midnight. It's kind of low compared to the others. So I kind of manually uh, customize my hourly bill bucket to be like this: 5 to 7, 7 to 19, 19 to 9. And then I also have the regular 6 hour bang. So basically, there's just 6 o'clock, 6 o'clock to midnight, no, 6 o'clock to noon, and noon to 6 p.m., etc. Based on that, that will extract all the feature simply based on the the entry time and exit time. So that gave me around 95 features. So at this point, my data prep is ready. I got the data that I need that I can do machine learning on it, right? So because this is was to try to predict what's the hourly occupancy number for each state. So it's a numerical prediction. So I was thinking using regression. So the simple regression would be linear regression. So I was just seeing, so I was just picking using the default linear regression to do my analysis. So first I was do some trend test split. So I basically split the trend test to be 9 to 1. So uh, 90% of the data set that is actually to be the training data set, and 10% to be the testing data set. That's just the old habit from uh, doing classification problems. So then I specify the linear regression, then fit the data set and try to do the prediction. And then it generates, and then I will have my final result. So this is the actually requester score based on the training set. It gave me about 73%, and this is actually using R square error. And the reason for R square error is this can tell you how much of the change in the output Y is explained by the change in input X. And R square is between 0 and 1. So 0 means your model is worthless, right? 1 is, yeah, 1 means like your model is perfect. Yeah, so that's just the general idea. So 73, yeah, so 0.73 is pretty good. But after I plotted out, I can't really see what's the trends look like and everything. I was like, all right, I'm just gonna redo the sampling, right? So I basically saying um, I will try to, yeah, okay. Um, so the problem we try to solve is try to predict what's the occupancy number in February 2016, right? So why don't we just train the data from 2014 and 15 and then predict on January 2016? And since we already have January 2016 data, so that'll be easier. So this is basically what I was doing, the sampling here, and try to predict on the data before January 1st, 2016. And this is the um, regression model score, and this is the actual score. 0.65. It's actually kind of bad, and the reason is there are a lot of negative value here, right? But it generally captured the trends in the data set, which is positive things, right? So if we can make the negative somehow to be positive, we, we, we can do a better job with this. So then I was looking at more documentation of how to do this type of things. Um, but one thing that we can do is cause basically apply some kind of log function on the target variable. So basically, we try to transfer that, and later on, so after the prediction, we can do a e to the x. The x will be what our prediction is. So that will make sure all the final results are actually positive, right? So um, Yeah, I at the very beginning I started using linear regression to do all the prediction stuff, and the result is similar like this, but it's definitely worse than this because this is the improved version of the graph. But by using linear regression, it's giving me the model score. It's fairly high, it's 0.83, and my actual score it's 0.63. It's still kind of low. So then I was thinking, all right, how can I do better in terms of um, choosing a better regression model, right? I mean, we already captured the trend somehow, but we just need to figure out what's the best for it. So the regression um, algorithm is basically try to minimize the sum of the square error, right? So there are basically two approach. One is ordinary least square, which is the default regression that scikit-learn was using, and the other one is by using gradient descent. So then I was looking at the documentation, and I find this thing called SGD uh, regressor. The full name is stochastic gradient descent, right? So basically, it was using random sampling, then do gradient descent on top of that. So after I choose that, it gave me really good score. Yeah, so this is actually the graph after I apply the SGD regressor. It gave me about um, 0.69, 0.687 ish by just simply using uh, out of the box SGD regressor. But then I was trying to see, all right, what are the parameters that I can change? One basic thing I can change is by changing the loss function. So I was trying using epsilon insensitive. It gave me 0.90. That's like really good in terms of R square error. I wasn't fully convinced or anything, so I did something else. Instead of try to predict January 2016, I try to predict what's the occupancy number for February 2015. So similar data processing, and I just fit in the different data to trend using different things, and here's the result. And as you can see, the graph show you, yeah, so the red dots means the actual value, and the green dots are the value that I predict. Right? Yeah, my predict result. So this is the regressor's R square error, 0.67. It's all right. But it gave me really good score in terms of my prediction data to compare to the actual data, 0.91. So at that point I was convinced, all right, this is the right uh, machine learning algorithm to use, and the rest is really just do a lot of uh, model tuning, right? So after that, I did a grid search. Basically, try some different parameter that I can use for stochastic gradient descent. And finally, I got a score to 0.91 for January 2016. And after that, I really just generate the final prediction for 2016 February. So here's a little heat map I created. Basically, also show the trends, right? So you have a better visualization, like what's going on from a higher level perspective. The line chart is basically that you can specify a time period that you want to see what's the hourly occupancy number looks like. here's my final prediction. So this is the sample that I did. I tried to predict on 2016 January. And here's the graph. And this is the R square compute on the fly. And see, it's fairly close, but I think I still have some room to improve. But we'll see. So here it's you can actually submit the final result and upload it. So my server will actually plot it out and actually calculate the R square error to give you a final scoring system. So with that, that's about it. And just to shout out for special thanks to BitTiger for providing this stage for us to learn and grow. Thanks, guys.